This looks like a perfectly ordinary window. Turn the handle sideways and it swings inward like a door. But turn the same handle upward and something strange happens. The entire top edge tilts toward you while the bottom stays attached. The first time you see it, the window looks broken. It is not broken. Hidden around the frame is a compact mechanical system that lets one moving panel behave like two different windows. And once you understand why it was designed this way, a surprising difference between European and American homes starts to make sense. In North America, people often call this a German window. Its technical name is a tilt and turn window, and you can find it across much of Europe, not just in Germany. On a typical model, the handle selects one of three positions. Point it down, and the window is closed and locked. Turn it sideways, and the sash swings inward from the side. This is the turn mode. Point it upward, and the top tilts into the room while the bottom remains supported. This is the tilt mode. The clever part is that you are not choosing between two separate windows. You are changing which parts of the same window are free to move. A standard door handle mostly moves a latch. A tilt and turn handle operates a network of metal rods, locking cams, corner drives, hinges, and a stay arm hidden around the sash. With the handle down, locking points pull the sash against the seals around the frame. The exact layout and number of locking points vary by manufacturer, but they all serve the same basic purpose, keeping the window shut while maintaining even pressure around its perimeter. Move the handle to the turn position, and those locking points release so the side hinges can carry the sash. The window can now swing fully into the room. Move the handle to the tilt position, and the hardware follows a different path. The lower support points stay engaged, while a metal stay near the top limits the opening. Instead of swinging sideways, the sash leans inward. One handle is effectively changing the geometry of the window. Many modern systems also include a safety mechanism that helps prevent the handle from selecting the wrong mode while the sash is open. Without that protection, or if the window is operated incorrectly, the sash may appear to hang from one corner. It can often be reset, but forcing the handle can damage the hardware. So the rule is simple. Close the sash against the frame before changing modes. The design met several needs with a single movable sash. It could open wide for fast ventilation. It could swing fully inward, making the outside surface easier to clean from inside the building. And it could tilt at the top when the user wanted a smaller opening without having a large sash swing far into the room. Instead of requiring a separate vent, a separate cleaning mechanism, and a separate full opening window, the hardware combined all three functions. At first, tilt mode seems like the star feature. It creates an opening along the top of the window, can reduce the chance of the sash slamming in a draft, and may offer some protection from light rain, depending on the design and weather. But here is the counterintuitive part. Leaving a window tilted all day is not always the best way to ventilate a heated home. The German Environment Agency recommends short periods of wide-open ventilation during cold weather, rather than leaving windows continuously tilted. Opening one or more windows fully for a few minutes can replace moist indoor air quickly, while limiting how much the surrounding walls and surfaces cool down. In Germany, this practice is often described as burst ventilation. So tilt mode is convenient, but it is not a magic energy-saving setting. During a cold German winter, full turn mode may actually be the better tool for a short, intense exchange of air. There is another important difference between a hinged window and a sliding one. The U.S. Department of Energy notes that casement, awning, and hopper windows generally have lower air leakage rates than sliding or hung windows because their sashes close by, pressing against the frame. The glass, frame material, seals, manufacturing quality, installation, and climate all matter. But the mechanism gives designers a useful advantage. The sash does not simply slide past a seal. The hardware pulls it into the seal. The inward opening also makes both sides of the glass reachable from inside. That is especially useful in upper floor apartments, where cleaning the outside of a fixed or outward opening window can be difficult. If this mechanism is so versatile, why did it not become the default everywhere? Because a window is part of a much larger building system. American homes have long used familiar designs such as single-hung, double-hung, sliding, and outward opening casement windows. Tilt and turn windows make different trade-offs. Their hardware is more complex, and the sash can be heavy. To open fully, it needs clear space inside the room. If a screen is needed, it usually has to sit on the exterior or use a retractable design. Installation, adjustment, replacement parts, and trained labor also depend on the local market. Tilt and turn windows also come with limits. A tilted window should not automatically be treated as burglar resistant. Some manufacturers sell specialized fittings that are designed and tested to resist break-ins while tilted. That tells us something important. A standard tilted window should not be assumed to provide that protection. A hardware needs proper adjustment and occasional maintenance, and the user has to operate it in the correct sequence. This is a mechanical system, not just a sheet of glass on two hinges. Most importantly, the opening style alone does not determine energy performance. A poorly installed tilt and turn window can perform badly, while a well-made American casement window can perform extremely well. The mechanism is ingenious, but it is not magic. A German window is a small example of how everyday engineering becomes almost invisible once people get used to it. At the outside, it is only a rectangle of glass. Inside, it is a carefully coordinated machine shaped by climate, construction, and habit. If you enjoy discovering the hidden engineering behind ordinary life, subscribe,